4.4. In the lesson for 4.4 in class today, the bulk of this was determining whether a rational expression was proper or improper. And we did that by looking at the degree of the polynomial. So the n was your top degree, the numerator. M was your denominator's degree. So we have the numerator and we have the denominator. If your top degree was smaller, you had a proper fraction. If your bottom degree was smaller, you have an improper fraction. So in this first part here, all you are doing is looking at your degree, your biggest exponent. So maybe that's a definition we need to remember. The degree is your largest exponent. And we looked at this in order to determine if it was proper or improper. So I'm going to let you guys work through 1 through 5 and use your notes, use your foldable if you need the definition of degree a little bit more, and shouldn't be too bad. Now 6 and 7, this is really bad to say. I'm not really too worried about you guys doing 6 and 7 right now. We haven't done a lot of talk within behavior of these rational functions. It's coming up not until we get to 4.6 and 4.7. It's not something I've chosen to focus on. So it's something you can come back and do, is 6 and 7 later if you remember. Now let's talk about the set. We have been talking about x-intercepts, y-intercepts, roots, asymptotes. We have not been spending too much time with end behavior. So let's just review x-intercepts. We've talked about the shortcut for finding x-intercepts. And if you look at your foldable, you should have on your foldable x-intercepts come from your numerator. You set each of your factors equal to 0 and you solve for x. Your y-intercept comes from making all of your x's equal to 0. Your roots, we need to remember, are your solutions. That is where the graph is going to cross the x-axis. So your x-intercepts. All roots, okay, real and imaginary, are your roots. Asymptotes. For asymptotes, I would like you to find your vertical asymptotes, which come from the denominator, and your horizontal asymptotes, which come from looking at the degree of your numerator and your denominator. Use your foldable. Now for end behavior, just so you get some practice doing this, you can look at the notes that we've done, but I'm going to say for now, type these into Desmos. Put them in there, look at the graphs, look at what their arrows are doing as x goes to negative infinity, as x goes to infinity. Are there any asymptotes that you're approaching? Should you put that in your end behaviors? Again, end behavior is something we're going to talk more about as we continue into 4.6 and into 4.7. So for now, I'm okay with you guys really focusing on those right there. And you could always use Desmos to check. Make sure you did everything correctly. Ooh, in 9, I'm going to give right there. Be careful with that guy, x squared minus 1. Be very, very careful. You need to do something with that x squared minus 1. Hint, hint. All right, let's finish up the set. So just like in the ready, you had to determine if a rational expression was proper or improper. You're going to do the same thing, but there's an addition. If it is improper, you are going to use long division to rewrite as a proper expression. Let's do, I don't want to do all of the long division ones for you. we've been practicing long division. Actually, I'm not going to do one for you. You guys can do one. You can do all 4 of these. You need that practice with the long division. If you have not been practicing the long division, yes, this is going to be tough. And you can go back and you can watch the video for 4.3. It's at the very beginning. Take your time. Don't make mistakes. If you make mistakes, everything is, your final answer will end up being wrong. It's just going to be very frustrating, and you're going to end up possibly giving up, not wanting to work through this anymore. Take your time, mistake free, please. And if you are stuck, you know where you can find me morning, lunch, and after school. Now let's look at the go. This is going to wrap up this section for us. Simplifying rational expressions. Factor cancel, factor cancel, factor cancel. Oh my gosh, I can't say that enough. Factor and then cancel. Factor cancel. You are going to have to look at factoring and canceling in all of these. In 14, 15, 16, and 17. I'm going to do 17 with you because 17 is already factored. I don't want to take the factoring away from you guys. You need that practice. So 17 has already been factored. And I look and I see I have an n plus 3 and an n plus 3. One's in the top, one's in the bottom. They cancel. They become 1. So I'm left with 2 over n minus 6. 2 times n minus 6 all over 4. Then you will need to notice that 2 goes into 4 twice. So your final answer is n minus 6 over 2. Very, very nice, easy problem to work through. Now let's look at 18 and 19. 18 and 19 differ from the first 4 because you are asked to add these 2 expressions. And we need to remember, before you can add or subtract, you need a common denominator. Unfortunately, neither one of these have a common denominator. So I will go ahead and do 18 with you. I'll do the hard one with you guys. So the left side has an x minus 5, but not an x plus 5. So I need to multiply by x plus 5. The right side has the x plus 5, but not the x minus 5. When I am working through this, I am going to, let me get this out of the way. I'm going to take my time with this. If this were me working in your book, I don't even think I would do this in my book. I would probably do this on another piece of paper, because you have to multiply x plus 5 times x plus 2. And you have to multiply x plus 3 times x minus 5. That's a lot of distribution. Here I get x squared plus 7x plus 10 plus x squared minus 2x plus minus 15. You are welcome to show the work. I'm using some mental math here. I distribute the x and then I distributed the 5. I distributed the x and then I distributed the 3. And I combined like terms in my head. Write it out if you need to. The denominator is x minus 5, x plus 5. Now I'm going to combine like terms in my numerator. I have an x squared and an x squared, so that's 2x squared. I have a 7x minus 2x, so 5x. And I have a 10 minus 15, so negative 5. This might be factorable. I don't know, but I'm going to try and see if I can factor the numerator. I'm not going to just leave it. If it is factorable and you don't check to see if it's factorable and something does cancel, I'm not going to be happy that you guys chose to not factor. And again, this may not be factorable, but I want to try it. So what multiplies to 5? Well, there's only 1 and 5. So if I put 5 and I put a 1, that's 10, and that's 1. Will a 10 and a 1 give me a 5? Nope. So now the only thing I have left that I could do is switch the 5 and the 1. That's 2 and that's 5. Will a 2 and a 5 ever give me a 5? Nope. So that one was not factorable. So I am done. Now you just have 19 to do, and that one's much easier. But be careful, always check for factoring and canceling when you guys are working through this. All right, that wraps up 4.4. If you have questions, please make sure you write them down and come and see me or ask me on our homework question days.